Hello, so we are here with the most important questions from trigonometry chapter for class 10 boards. So you see we have this question over here, sec theta plus tan theta is equal to x. Then what will be sec theta minus tan theta? You have these options over here. So we have this formula 1 plus tan square theta is equal to sec square theta. So in place of 1 I can write what sec square theta minus tan square theta. Now if you see sec square theta minus tan square theta is what? Sec theta minus tan theta into sec theta plus tan theta. Now if you see sec theta plus tan theta, this stuff over here is given to you as x. So basically in place of this purple I'm gonna write x. So we will have 1 is equal to sec theta minus tan theta into x. So if you get the x on the bottom, you will have sec theta minus tan theta. This will be 1 upon x. So basically your option D is absolutely correct. I hope you understood this question. You can pause it and read this question. Meanwhile, I'll move to the next one. So the next question is we are given sine A plus B. Sine A plus B is equal to 1. Cos A minus B is equal to root 3 by 2. Both A and B are greater than 0 degree but less than 90 degree. We are supposed to find measures of angle A and B. Find measures of angle A and B. You see here sine A plus B is 1. In place of A plus B I can write which angle gives me 1? 90 degree of sine. So A plus B is 90 degree, right? Which angle of cos gives me root 3 by 2? It is 30 degree. So A minus B is 30 degree. Now you have your chapter in class 10 linear equation in two variable. So if you simply add equation 1 and 2, if you add equation 1 and 2, we will have 2A is equal to 120 degree, which gives me A equal to 60 degree, right? If we place A equal to 60 degree in equation 1, put A equal to 60 degree in equation 1, we'll get 60 plus B is equal to 90 degree, which gives me B is equal to 30 degree. So thus your answers are A equal to 60 degree, B equal to 30 degree. You can again pause and check this question. I'll move to the next one. So you see we have this question over here, sine theta plus cos theta. This is given to you as root 3. We are supposed to prove that tan theta plus cot theta is equal to 1. So please see, we will square both sides given here. In such questions it is always good to square both sides, okay? So sine theta plus cos theta is equal to root 3. We'll square both sides. So sine theta plus cos theta whole square is equal to root 3 whole square. So this gives me, applying the A plus B whole square formula, sine square theta plus 2 sine theta cos theta plus cos square theta, root 3 square is simply 3. Sine square theta plus cos square theta is 1. 1 plus 2 sine theta cos theta is equal to 3. This gives me 2 sine theta cos theta. This will be 3 minus 1, that is 2. So solving, sine theta cos theta comes out to be as 1. So we will mark this stuff over here as equation number 1. Now tan theta plus cot theta, this we are supposed to prove that as 1. So let's see, we can write tan theta as sine theta by cos theta. Cot theta can be written as cos theta by sine theta. If you take the LCM over here, you will have cos theta into sine theta. Cross multiply, you will get sine square theta plus cos square theta. This gives me 1 upon cos theta sine theta. Using the identity, sine square theta plus cos square theta is equal to 1. Okay students, I hope you are aware of this identity. So now if you see from equation 1, what is sine theta cos theta? It is 1. So I can write here 1. Okay, so my RHS is proved. Okay, you can, I'm just zooming it out, you can read this question once. Okay, you can pause and read this question. I'll move to the next one. So you see, we have this question over here. Prove that cos A, prove that cos A minus sin A plus 1 upon cos A plus sin A minus 1 is equal to cosec A plus cot A. Now this question comes for 5 marks. What I'm gonna do in LHS here, I'm gonna rationalize. I'm gonna sort of rationalize this stuff here. Not rationalize as in the way we rationalize. Okay, basically you have cos A minus sin A plus 1. What I'm gonna do, you have cos A plus sin A minus 1 on the bottom, so you multiply with cos A plus sin A plus 1 on top and bottom. Cos A plus sin A plus 1 on the bottom. Likewise, cos A plus sin A minus 1 into cos A plus sin A plus 1. If you see here, cos A into cos A gives me cos square A. Cos A into sin A gives me cos A sin A. Cos A into 1 gives me simply cos A. Minus sin A into cos A gives me minus sin A cos A. Minus sin A into sin A gives me minus sin square A. Minus sin A into 1 gives me simply minus sin A. 1 into cos A gives me simply cos A. 1 into sin A gives me simply sin A. 1 into 1 gives me simply 1. On the bottom, if we see a minus b into a plus b, which is a square minus b square. Cos A plus sin A whole square minus 1 whole square. Now if you see cos A sin A minus cos A sin A gone, then you can see minus sin A and plus sin A gone. Cos square A will remain as it is. This cos A over here, please see carefully, this cos A over here and this cos A over here will give me 2 cos A. So plus 2 cos A, right? Then we are left with this sine square A and this 1 over here. So I'll write 1 and then minus sine square A. On the bottom, if you open this stuff over here, you will have cos square A plus sine square A plus 2 sine A cos A and minus 1. You please see here cos square A plus 2 cos A, then 1 minus sine square A is cos square A. On the bottom I can write cos square a plus sin square a as 1. This is 2 sin a cos a, and over here I have minus 1. So if you cancel the 1 and minus 1, you have cos square a plus cos square a, which gives me 2 cos square a. This is plus 2 cos a, and on the bottom I have 2 sin a and cos a. If you take 2 cos a common, you will have cos a plus 1 upon 2 sin a cos a. We can cancel the 2 and 2 out, cos a out. So we'll be left with cos a plus 1 upon sin a. If you split the stuff over here, cos upon sin gives me cot a, 1 upon sin gives me cosec a. Now if you go back to your RHS, this is exactly what we need to prove. So if I would recommend any student of class 10 to practice 4 or 5 questions of trigonometry for a board exams, these will be it. Okay, thank you.